Okay. Hello, Professor. My name is Kenny Kamara. Today, I'm going to be doing lab number 9's problem number 3. So let's to prove that u and v are parallel, the vectors, if and only if u cross product vector v is equal to 0. So, there's my mouse. To start off, I'm going to start proving the first part right here, where I say let the vector u times vector v is equal to vector 0. This cross product is actually is equivalent to the magnitude of vector u times the magnitude of vector v times sine theta. And in this equation, for our case, let me write it right here, vector u and vector v cannot be equal to 0 because they have to have a length in order for them to actually be parallel. And so all this implies that the cross of u and v is equal to the magnitude of u and v times sine theta, which we are looking to get equal to 0, where theta is going to be the difference in angle between the two vectors u and v, and so far it's of course all equal to 0. And this implies that sine theta is equal to 0. The difference in angle between vector u and v is equal to 0. And so for this to be true, it means that the oops, let me delete that. It means that the angle between must also be 0 for them to actually be parallel. Meaning all this basically means that the difference in angle between a vector u and a vector v has to be 0 in order for this to be true, which implies that vector u is parallel to vector v. So that's the first half. And now to start on the second half, since this is an if and only if, we need to prove it the other way around. So if we let vector u be parallel to vector v, this implies that theta is equal to either 0 degrees, meaning they're on the exact same, or it could also theoretically be 180 degrees, meaning it's in the opposite direction, but still on the exact same line. Which means that the cross of u in v, as I wrote before, is equal to the magnitude of u in v times sine theta, where of course theta has to be equal to either 0 degrees or 180 degrees, which means, let me write that down real quick. So we have the magnitude of both u and v, and then we have sine 0 degrees, and we also have the exact same thing, but with sine 180 degrees. However, both of these are equal to 0 in the end because sine of 0 degrees is equal to 0 and a sine of 180 degrees is equal to 0. And of course, if this is 0, it means that the actual values of the magnitude of u and v are irrelevant, meaning it will just equal 0 in the end, which, since this is all equivalent, that means that the cross of u and v is equal to 0, thus proving that vector u and vector v are parallel if and only if the cross between them is equal to 0. Okay, thank you.